Hi guys, hope all of us are doing great. I'd like to welcome each and every one of us to my channel of Honesty Sciences and Mathematics TV channel. I'd first like to appreciate our members who have already joined the group. Kindly I'd like to request us to go to YouTube, search Honest Sciences and Mathematics TV channel, subscribe and follow the link that we usually put in our description boxes so that we can be getting other updates that are related to these specific topics under discussion. So in that particular case, today we're going to look at a topic in biology, and that is concerning the concept of what we refer to as the skeletal joints. So in this particular aspect, I'd like to mention that we have discussed some of the aspects of the human support system in our different videos in details. And this concept of joints, of course, is basically trying to look at various connections that these bonds, of course, articulate in order to bring about the concept of movement. Now, in this specific discussion, we're going to see that these specific joints fall under different categories, and that depends on their structures and features, and perhaps some of the materials, of course, which are contained in these specific joints. Now, we're going to see that there are different formations of these particular joints in functions and shapes, and of course, we're going to look at them in these specific categories that I'm going to mention later. Now, of essence of what I've mentioned concerning the structures and functions, this, of course, on functions, this is going to be dictated basically from their degree to display the concept of motion, whereby we're going to see that some of the joints are going to be totally immobile, where others are going to display some, of course, slight degree of movement, where others are going to be, of course, having what we call basically immovable joints. And therefore, I'm going to use various illustrations in trying to try to show this specific case. Of course, from the example that I've given on the board on the appendicular part of the skeleton of the upper limb, and this is a point of course, it's a junction between one of the bones of this, let's say, appendicular skeleton, that is a scapula, together with the humerus. And of course, we're going to see that the ulna and the radius also articulate to the humerus at this specific point, and these extremities of the upper appendicular skeletal system for the hand is going also to display some wide ranges of joining of these specific bones. Now, I'm going to categorize these bones as either movable, immovable, or partially movable part of these joints, where we're going to see that that's a classification that falls under functions, as I've said. Now, the second category of bones is going to be classified according to structure, as I've said. And this is going to depend on what basically forms a part of those specific part of the joint. Now, we're going to see that some joints are going to be formed by thick connective tissues in between them, which basically are going to be fibrous. Therefore, these are going to be classified as fibrous joints. Now, in this particular case, we're going to see that these thick fibrous connective tissues are going to limit their degree of movement, and therefore we're going to see various joints that are going to fall under this class and their range of movement in particular. Now, in my next, of course, this proceeding discussion, we're going to look at this classification of joints according to structure and details, and that is going to be, of course, an expansion of the fibrous joints, cartilaginous joints, and the synovial joints that we're going to look at the end of our discussion in this particular case. So to start with, we're going to look at one of the examples of the fibrous joints that we have already discussed in a different video, of course, that was different from this particular case, but it's going to be relevant for us in understanding this specific category of joints. Now, if I try to look at the frontal view and the lateral view of the human cranium, and we looked at this specific part, and I've, of course, mentioned that basically this type of joints which are found here are made up of thick connective tissues, therefore giving that a particular class of joints that we're going to classify under structure, which basically I've mentioned to be fibrous joints. So in this particular case, fibrous joints are going to be, of course, exhibited in this part of the human skeletal system, and these are in form of surters. Now, we have discussed the concept of surters in one of our videos, and in this particular case, I'm going to mention the various surters, basically which were 4 in number, that we had looked at that specific video. Now, these surters are going to form, of course, non-moving joints or immovable joints that are connecting bones of the skull. And one of them, of course, The one that is connecting the occipital bone and the parietal bone is referred to as the lambdoid sulta. And this next is the squamous sulta that connects the temporal bone and parietal bone. And this specific point, the parietal bone and the frontal bone are connected using the coronal sulta. And of course, there was that last bit, of course, which we had mentioned. I'm trying to the sagittal sulta that is found between these two parietal bones, of course, from the superior view of the skull in this specific case. So those ones fall under the category of fibrous joints. And therefore, we're going also to see that I've mentioned the articulation between the bones to the mandible and the what we refer to as the maxilla. At this specific points, the bones and the mandible and the maxilla are going to be joined to these specific two parts using the fibrous joints respectively. So apart from that, there are two main types of bones of the limb that are, of course, looked at in our classification of bones, which, of course, are going to also display this aspect of fibrous joints, which, of course, is the ulna and the radius at this specific point. So we're going to see that there's a specific ligament that is going to join these particular bones at this particular part, which is going to connect the two bones to allow for little movement at this specific point. And that one we refer to as the syndesmosis. And of course, it's going to fall under the broader category of joints, which are going to be referred to as the fibrous joints. Now, the second category of joints, according to structure, are going to be the cartilaginous joints. Now, apart from the fibrous joints that fall under the category of classification according to structure, the second one we have is cartilaginous joints. And these are joints that unite bones, of course, with the cartilage. Of course, I'm going to use this one of the examples that I've listed on the board. And this is the bones of the chest, I mean the thoracic cavity, that I'm going to, of course, use this specific illustration for that. So if we try to look at this specific point, we've got what we refer to as costal cartilage, and this is going to form part of the bones which is connecting the ribs together with the sternum at this specific point, and therefore this falls under the category of cartilaginous joints. And we are going to, of course, see that these particular bones form a range of bones which are going to be under the immovable joints. And for instance, the first pair of ribs to the sternum at this specific point, this is number one. We are going to see that they are going to form part of this joint that we have referred to as the cartilaginous joints. And specifically, this is going to be referred to as the syngiodrosis part of this specific joint that we have called the cartilaginous joints. We're going to see other categories that are, of course, formed by the fibrocartilaginous connective tissues. For instance, the hip joints and the vertebrae column that we're going to use at some point in our discussion. And those basically are going to be falling under the category of bones, I mean joints, which are being named after their, are according to structure. The third category that I had mentioned are synovial joints, and these synovial joints are going to form a wider range of bones which are going to be displayed throughout the skeletal system. And the number we are going to see that they are basically pronounced in that they are around 200 and over 200 kind of these synovial joints in the body. And one of the characteristics or features of these particular joints, we're going to see that they contain what we call a capsule. And this capsule is consists of what we refer to as synovial membrane and the fibrous capsule that form part of this specific surface of the joint. Now, these particular bone surfaces are protected by this articular cartilage, which, of course, we're going to see that it plays a vital role in trying to protect these particular sections for the bones. There's this fluid that is filled in between these particular parts of the cartilage, which is referred to as synovial fluid, of course, which acts as a fluid that is protecting the movement and trying to ensure that there's no friction that is going to be, of course, realized at this specific point of the bone. And now this particular joint has got a particular degree of movement, and we're going to see that these specific points, there are various ligaments which are going to be surrounding this particular point of bone in order to control the degree of motion and therefore trying to prevent an aspect of injuries. Now we're going to see different types of, as I said, there's a wide range of synovial joints in the human skeletal system. We're going to see different types of synovial joints, which are going to be, of course, contained in the skeletal system. And of course, they are going to fall under the categories of these other joints that we have mentioned. But of essence for us to discover is that there are some degrees of motion which they are going to display according to different axes, as we're going to see, and the various angles of extension that we are going to display insofar as movement is concerned. Now, our first type of synovial joint that we're going to look at is the plane joint. And this is one of the classifications of the joints that we are going to consider, of course, insofar as their shapes are concerned. Now, the plane joint basically consists of a joint that, of course, is formed between bones in which, of course, the articular surfaces or the surfaces of the bones are nearly flat. And therefore, we are going to see that these bones can slide over each other to some degree of movement. And one of the examples of this type of joint that falls under the category of plane joints is the intervertebral. Of course, this is found around this intervertebral disc that we're going to, of course, see under the vertebral column. And therefore, this particular type of joint allow for some of the degrees of movement, particularly in trying to ensure that the bones can slide over one another. And physically, they contain roughly a flat or a nearly flat surfaces. Now, apart from the plane joints, we're also going to see a second category of a synovial joint that we refer to as a pivot. And the pivot joint, basically from the is going to allow for some degree of rotation. Of course, that is going to be found in the ulna and the radius, and that falls under the category of the proximal radioulnar and the distal radioulnar sections of this specific radius. Now, I'm going to use another illustration. I'm going to mention that one, where it's basically going to be somehow elaborate for us. Now, the next, of course, type of joint that is a synovial joint that is going to fall under this specific category of course, synovial joints is the Hing joint. And basically for the Hing joint, it allows for motion, particularly in one plane. And we're going to see that this particular type of joint can be found in the articulation between the humerus, ulna, and the radius at this specific point. Therefore, we're going to, of course, see and expand on that one when we're going to talk about a particular concept on this set of what we refer to as the broader topic of movement. Now, apart from the plane pivot and Hing joint, we have what we refer to as the ball and socket joint. And in some of our texts, we're going to see this joint being named as the spheroid joint. And this is a type of synovial joint that is, of course, which has got one of the bones, or rather this end of the bones, assuming a ball-shaped surface. And of course, the rounded bone is going to fit into a cup-like structure over this part of the scapula that I've mentioned in this specific point. So this is one of the type of synovial joint that we're going to refer to as a ball and socket joint. And insofar as the degree of rotation is concerned, we are going to, of course, see later that it's going to allow a motion in an indefinite number of axes as compared to other another type of joint that is referred to as the saddle joint. And the saddle joint is a joint that allows movement in two planes. And we're going to see that this particular kind of plane, of course, allows for what we refer to as flexions or extensions, and abductions or adduction that we're going to see under movement in our next discussion. So mainly we are going to see that this particular articular surfaces for what we refer to as the saddle joints are going to contain the concave and convex regions, which are going to articulate together in order to facilitate this concept of movement. Now, one of the examples of these particular types of joints that I've referred to as saddle joints are going to be found in this couples part of of course, the hands, which we're going to see later in an expanded form. But basically, this one allows movement in two degrees, or rather what we refer to as two planes, respectively. So the next type and the last one is one of the biaxial joints. And biaxial, we mean that one, of course, allows movement in two planes. And therefore, the next one is going to be an ellipsoid joint. And this ellipsoid joint is a biaxial joint that we're going to see being displayed. Of course, I'm going to show it in an expanded form, this specific section of what we refer to as the wrist joint, which is going to form part of that synovial joint, a product class of synovial joints, as I've mentioned. So if we come across these specific different types of joints for the ball and socket, the ellipsoidal, the saddle, the plane, pivotal, the hinge joint, in our various parts of the human skeletal system, then therefore it will be easier for us to try and identify them as per our discussion. Now, of essence for us is to understand these specific features, which of course we have mentioned concerning different types of joints, and we have said that they are classified according to their, of course, features and functions, and in this order, structure and functions. And in this particular case, we have mentioned different types of sockets, ranging from ball socket, ellipsoid, saddle, plane, pivot, and hinge joint, which basically forms the different parts of the skeletal system, as we have mentioned. And of course, we have identified a few examples of what we have seen for the different types of joints. For instance, we have talked about the humeral joint that is, of course, going to fall under this category of ball and socket. And of course, for the ellipsoid joints, we mentioned of course, the metatarsals bones, which is articulating to the phalanges, which forms part of the what we refer to as the ellipsoid joint. And for the saddle joint, we are given an example of the sternum and the clavicle, which are joining in the upper part of the appendicular skeleton, in that part of the thoracic cage or the thoracic section. Of course, that one forms part of what we call the saddle joint. And this is a movement in two planes, which we said is biaxial. And for the plane, of course, we said about the intervertebral discs, which are going to form slightly or some flat surface, whereby these joints are going to be articulating for the vertebral column from one bone to another. And we talked about the concept of a pivot joint. And of course, this one I give an example of the ulna and the radius. And this basically, there's a ligament that is trying to join this one to allow for some degree of movement that I had mentioned, of course, in our discussion. And lastly, we talked about the concept of a hinge joint. And I'd given an example of elbow section, which basically consists of what we call as a cubital section or cubital part of joints, which are going to fall under the category of these synovial joints that we can refer to as, of course, the cubital joints or the synovial joints. And in this particular case, I'd like to request our members to check on our description boxes for various videos. This video, in collaboration with others, is going to assist us, of course, understand the whole essence of movement in the human skeletal system, which is going to assist us, of course, appreciate the overall role of support and movement, among other topics. So that is it for now, guys. Bye. God bless you.